coming to the next problem, a complete n-ary tree is a tree in which each node has n children or no children. Okay, so there is a tree in which each node will have either n children or no children. Okay, and let I be the number of internal nodes and L be the number of leaves. Okay, in a complete n-ary tree, and then we are given the value of L and we are given the value of I, and we have to find the value of n. So that's what we have to do in this case. So this means that if you try to look at what will you get. Okay, so suppose this is your root, you might just stop here. This might be an n-ary tree for you. Or if you will have children, you will have n children. Okay, if you stop here, you have no children, you are fine. This is an n-ary tree. But if you want to have children, okay, and like this, so you must have n children. That is the condition. Okay, like this. So there are, you can say that there are n children. Okay, and then for these ones, if you want a children, you have to have n children. Okay, go ahead and have n children. Okay, otherwise don't have children. That's the idea. Or okay, so for this one, suppose there is no children, so it's fine, no children, it will be a leaf if there is no children. Okay, and this one, if there are children, there will be n children, otherwise it will be a leaf. The same thing will apply to any n-ary tree. Okay, so that's the idea of n-ary trees. Okay, and then there are leaves and there are internal nodes. So your total nodes are divided into two parts, so they have been partitioned. Okay, either you have so in total you have these leaves and what is internal. Okay, so what you can say is that your total number of nodes is the number of leaves plus the internal nodes. That's what you can say for sure. Why? Because any node will be either an internal node or a leaf. Okay, a node that is not a leaf is an internal node. That's the definition. So this thing is fine, and then you have to find this n. Okay, how many children this node can have? Either 0, if not 0, then how many? That's what you have to answer. So what you can do is you can think about total number of nodes in another way. Okay, total number of nodes in another way. Okay, so any node, okay, if you look at any node other than root node. Okay, so for now forget about root node. If you look at any node, it will be a children of some node. Okay, and that node will produce exactly n children. Okay, so what you can do is, for these internal nodes you will always have children. Okay, and if you take all the internal nodes except the root node, okay, we are not talking about root node right now, and you take their children and you do that for all the internal nodes, what you will get? You will get total number of nodes except the root nodes. Okay, so if I take all the internal nodes, okay, that is I, and these are the total internal nodes. Okay, and this root is also an internal node. Okay, so root is not counted as the total number of nodes, but it is counted as internal node. Okay, so we're talking about all the internal nodes, and you multiply this with n. Okay, so what is this? What do you get when you multiply this number of internal nodes with n? N is the number of children a node can have if it doesn't have any, if it is not the case that it has no children in that case. So what it gives you ultimately is all the nodes except the root node. Okay, because this root node cannot come from some parent. Okay, and for every internal node, if you multiply by n, you have generated their children. So this gives you all the nodes except the root node. Okay, and for that root node you have to write plus 1 extra. So this is another way of looking at total number of nodes. Okay, so if this is one way of looking at total number of nodes, is just to add the number of leaves and the number of internal nodes. This is the another way. And if you equate these two, okay, if you equate L plus I is equal to I n-I, let's write it n into I, n-I plus 1, and if you substitute these values, you should get your answer, which is 41 plus 10 is equal to n into 10 plus 1, and from here this will be 51 and this will go here minus 1, so this will give you n into 10 is 50, which means that n is 5. Okay, so that is the correct answer. N is equal to 5.